Okay, I think we'll get started. We may have a few more people joining as we go along, but I'll get going for now and hopefully they can catch up. And my name is Adrian Jackson, and I'm from EPCC, the University of Edinburgh, and I'm going to be giving this Introduction to ARCHER2 for Software Developers course, along with my colleague Kevin Stratford, who will be around, and my other colleague Claire is also here as well. I've got my video on for now, just because I think it's nice to be able to say hi to everybody, but I will switch it off shortly because, given that, as you can see, I'm in my dated living room here, the bandwidth at home may not keep up with me streaming my video and my audio at the same time, so I will switch it off shortly. A couple of things to say up front. Apart from apologising for the extraneous noises that will happen, given that I'm presenting this from home, what is that we're recording this session, so all the lectures and the chat that we're doing today will record and tomorrow. So if you have a problem with that, please do let me know. You can drop me an email, or you can put it in the chat now. My email address here in the chat window, you can see it as well. And in general, the plan is that these recordings will go up online for people to peruse at their leisure later. And so again, if you have problems with that, do let me know. And the other thing I should say is that we're using a sort of software carpentry style teaching method for this course, which is all the lecture material and the practicals are outlined on a web page, which you can go through in your own leisure and your own time. I will work through this page as we're teaching this course, but if you are wanting to rush ahead or I'm going too fast, you can work through this web pages at your own rate. But I'm using a slightly different web page than the one that may have been listed on the ARCHER2 website or potentially sent you an email link. And so I put that into the course chat here. It's adrianj.hpc.github.io. A link which hopefully you can see in the chat. I'm using that because I've had to make some minor changes to the course content from the main course, and the changes have been pushed into there, but are not updated in the main site at the moment. So that's the one I'll be going from. That's the one hopefully you can see on your screen now, where it says Intro to ARCHER2 for Software Developers. And so that means that whilst you can listen to me, it's probably sensible, and watch what I'm doing, it's probably sensible for you to have this open in a browser yourself, so you can go through it and see what I'm seeing. And there'll be little bits and pieces of examples for you to play around with. Just before I go through what we're trying to do in the course and those kind of things, I should point out that we have a timetable here in this web page, which is slightly different from the timetable we'll be following. So we've started at 10 o'clock today. Actually, today we'll finish at 4 o'clock, and then these two sessions we will do on tomorrow morning. But tomorrow is generally set aside actually for you to play around with the ARCHER system. So there's not very much talk content apart from these how to be a good ARCHER2 system using safe and next steps, which are really not going to take up very much time at all. The idea is that you can get onto the system and play around with it, and that may be taking your own application and running it on there, or we provide you with an example application which you can play around with tomorrow. And so you can see here that the timetable is slightly different compared to what has been advertised, in that the talk material really only lasts until tomorrow lunchtime. But in reality, the idea is that I will be around and my colleagues will be around from 10 till 4 tomorrow. We'll get you going in the morning, but the idea is that you can play around with the system and then come and ask us any questions that occur to you, or any problems that you have, you can come and discuss with us. with your applications or with the example application. So it's a sort of more like a consulting session tomorrow. Does that answer your questions, Doug? And does anybody have any questions about this timetable other than that? Great. And now the timings here may also change slightly, because this is a relatively new course. This is the first time we're running it on the large scale ARCHER2 systems. So it could be that we take longer in some places and shorter in other places. But this is the general idea. We're going to go through this. As I've said, if you want to do this at your own pace, there's nothing to stop you going away and doing that. No problem with that at all. Okay. The other thing that I should say up front is that given that we're running this for the first time and we have this new ARCHER2 system, I appreciate the audience may be slightly different to what the course is designed for. So in general, the course is designed for people who are sort of knowledgeable with HPC systems, but want to develop and run on ARCHER2. So it's one of the specific things about ARCHER2 that you need to know to run, and how do we get onto that system, and how do we run on that. So in general, it's sort of entry level course for a system like ARCHER2. I appreciate though that given the strange situation we're in here now, when most people haven't had access to the system yet and it's brand new, we may have more advanced users on this course. We may have people here who are quite heavy users of Archer or other HPC systems, and that may mean that some of the material I'll go through today is a little bit basic for you. Apologies if that's the case. All I'd say is that we're going to give you access to the system, so if you just want to go off and play on the system and refer back to the lectures and drop in and out, that's perfectly fine. I'm more than happy for you to do that. We'll get going on getting you on the system, and away we go. But for those who are more interested in the full thing, that's perfectly fine. You can stick around and run through with me what we're doing. Perfect. So the other thing I should mention, apologies, is that this course is really designed when we have a full Archer system. And so the full Archer system we don't have yet. I'll talk about that a little bit more in the overview of the Archer system lecture next. We don't have the full, more than 5,000 nodes with all the different functionality we'll have in there, such as large memory nodes, pre and post processing nodes, GPU aspect, and some of the other file system things. So a couple of things that will be mentioned on these web pages are not applicable to the current incarnation of ARCHER2, which we're calling the ARCHER2 4-cabinet system. And that's because physically it's made up of 4 cabinets. And it's still quite a big system, the ARCHER2 4-cabinet system. So it's 1,024 nodes, and that actually, because there's 128 cores per node, it equates to something which is of similar size to the current Archer system, at least in terms of number of cores, although it's nowhere near as big in terms of number of nodes, because the current Archer system is around 5,000 nodes, I think, and we only have 1,000 nodes here. When it's finished, we're going to have 23 cabinets on the ARCHER2 system, so it's going to be quite a lot bigger than it currently is, but it's still a reasonable resource at the moment. So there'll be points where I discuss things in the lecture material which we can't actually access at the moment. But it's there just to give you an idea of what's coming on the system. The other thing that we need to make sure you have access to is an account on the actual system. So I know in the past, when we've run these kind of courses, what we've done is set up generic guest accounts for people to use, and handed them out at the course. But that's not the way we're going to do the training now from a ARCHER2 perspective. What we do is we have a project on the system. Everybody signs up for their own individual account. And that means that for you to be able to do the practical side of this course, you need to have an account on ARCHER2, and you need to have signed up for that account on ARCHER2, and I need to have approved it and I know I've approved a number of accounts over the past couple of days. Apologies, I know it has all been a bit last minute, a bit short notice. But I also know that I haven't approved as many accounts as there are people here. So if you've not got access to the ARCHER2 system yet, if you've not tried to sign up to it, that will be something good to be doing whilst I'm talking. Now, we don't actually need to do that until we get to this lecture at 11:30-ish, connecting to ARCHER2 and transferring data. But what I'm going to do is, you should all have had an email, I think from Claire, actually saying how you access the system, how you sign up for it. But I'm going to paste that into the chat here as well. So in case you've not gone through that process, you know how to do that. So let me just copy and paste that into the chat. So it's worth you doing that now, because it takes a little bit of time for the accounts to be set up. And I will keep an eye on the approvals coming through and enable them as we go. It don't worry too much, because we have the time to sort out errors and issues in this built into the schedule. So don't worry about that. Does anybody have any questions before we start in earnest? I'm going to switch my video off now as well, so as not to distract you too much. Okay. If no one has any questions, then we'll go on to overview of a ARCHER system. Thank you, Gavin. Okay. So this is a standard to some level, for whatever standard means, HPC system, in the sense that it's located somewhere remotely. Actually, it's sitting in Edinburgh, sitting in our data center, the ACF, which is actually sits slightly outside Edinburgh. And it has a large number of compute nodes connected together with login nodes that enable you to access the system, compile your job, and then submit your jobs onto those compute nodes. Once we have a full system, there'll be 3 different kinds of nodes that we have available. We have these login nodes, compute nodes, and then some data analysis or pre and post processing nodes. And those data analysis or post processing nodes are not yet available, and they'll come early next year along with the rest of the full system. At the moment, we have a set of login nodes and we have a set of compute nodes here. All of the nodes actually will end up having the same kind of processors, so the login nodes and the compute nodes. So actually, when you're in the login nodes, you're on a system which is very similar to what you'll be running on the jobs on. They're based on AMD EPYC processors, so these AMD EPYC Zen 2 processors, which has 64 cores processor, and there's 2 processors per node. That means we have 128 physical cores per compute node and per login node as well, actually. That's quite a big increase from what we had on the current ARCHER system, which is the Intel processor was only 24 cores per node. So we're going from 24 cores all the way up to a 128 core node. And there you can see why this 4-cabinet system, which has only 1024 nodes, can still have a similar number of cores to the existing ARCHER system, which has got 5,000 nodes, because it's got approaching 5 times approaching 6 times as many cores per node as the existing ARCHER2 system has. So when the full ARCHER2 system comes along, there will be 5,800 nodes, approximately, with about 750,000 cores in them. There will also be 2 different kinds of compute nodes, standard compute nodes and high memory nodes. And so the high memory nodes have 512 gigabytes, and the standard memory per node, and the standard compute nodes have 256 gigabyte memory per node. Now, again, those high memory ones are not available yet, so they will come in the later system. At the moment, we just have 1,024 standard compute nodes, each with 256 gigabytes of memory in them. 200. So we've got a table here which shows us a comparison between Archer and ARCHER2. Again, 256 gigabytes memory is a big expansion over what we have on the current Archer system, which is 64 gigabytes. It's about, it's 4 times as much memory. But then we've got to remember we've got over 5 times as many cores in these new nodes as well. Okay, so we have more memory and more cores per node in the existing Archer system. What else is going on in here? Well, the AMD processors are slightly different to the Intel ones we have on the current Archer system, in that they are split up into what we call these NUMA regions. And there's 8 NUMA regions per node, or 4 NUMA regions per CPU. 16 cores in each NUMA region. And most of the time, you probably don't have to care about this. But all it means is that we have 256 gigabytes of memory in the node, but actually it's split up into 4 chunks of 64 gigabytes each, and 16 cores are physically attached to each one of those chunks, and that means that in each one of those chunks, if a core accesses its local memory, it's faster than accessing any of the 64 gigabyte chunks outside its local group of 16 cores. And that means for some applications, you have to care a little bit about how you split up the data across groups of cores, more than you did on the previous Archer system. Most applications, this is an issue, but if you're doing hybrid programming where you use an OpenMP and MPI or some equivalent version of that, or if you're doing just OpenMP programming, this may be something you need to consider. And we'll talk later in the day about how you make sure you know where the applications are running on which groups of cores and which numerals. So that is a difference, but actually for most applications that run on a system like Archer, it's a difference you don't have to worry. One of the nice differences between Archer and ARCHER2 is that the AMD processors have a higher memory bandwidth than the Intel processors on Archer. They've got more memory channels and they've got a higher memory bandwidth, which means that codes which are quite memory dependent, memory bandwidth dependent, should get a good performance improvement when we come across to that. And then we are connected together by a Cray network between the compute nodes, and that's Cray's Shasta interconnect, so it's a new network, and it too should be faster than the one on Archer, although it's a completely different network setup. So we're still, looking at performance and the impact that has on applications. So far, so good. So that's the raw compute we have on ARCHER2. As well as compute, you're also going to need somewhere to store your data. So just like on the Archer system, we have 2 different file systems. We have a home file system where when you log into, that's where your directory is. It's on the home file system, and that is actually backed up. All the data in there is backed up. We also have a work file system, which is much larger, is not backed up, and is a parallel file system. So that's the one you can use to get good performance on the computer. And this is exactly the same as what on the Archer system. If you've been an Archer user, we have 2 file systems. One's small and backed up, and that's home, and one's large and fast, not backed up and work. And just like on Archer, this home file system is not visible from the compute node, so everything you have to do has to be on the work file system, when you're running your compute jobs. You can build and compile and do little bits and pieces on the home file system. When you're running a job, everything has to be on the work file system. Home for source code and things like that, and small amounts of data, work for large amounts of data, and for your running jobs. There's also will be, when we get this final Archer system, the full Archer system, a solid state storage file system as well. We don't have that yet, so I'm not going to go into too much detail. The idea is that this solid state thing is like work faster, smaller and faster. So it's a smaller, more high performant file system which could benefit some jobs. And the idea, if you've ever heard of something called burst buffer, it's a technology that's quite often used in high performance computing centers, where jobs do all their fast I/O to this solid state storage and then copy it off onto a larger file system after the job has been done. So that performance and complexity will come in next year when we get the full system, but it's not quite here yet. The one thing I would say is that if you have been used to running an ARCHER2, the difference between home and work file systems is more pronounced, in that you cannot even submit a job from the home file system anymore, really, without a lot of effort, and you can't do what we used to do on Archer, which is submit a job from the home file system and still access your executable from the home file system. You really just have to have everything on the work file system, otherwise the jobs will fail. And annoyingly, at the moment, if you try and submit a batch job from the home file system, and I'm getting slightly ahead of myself here, if you try and submit a batch job from the home file system, it submits, but you get no error message and you get no files appearing, just because the way the batch system works, it can't see that file system, so it can't tell you that it can't see the file system. So in reality, we have this setup which is a bit more stringent than the original Archer system, in that you just have to do everything computationally from the work file system, and then copy things back to the home file system if you want them backed up. Yeah, but as long as you follow that rules, as long as you understand there's a difference between home and work is the only place you can submit jobs from, and then anything in that job needs to be on the work file system as well, executables and data, then it should just work as it did on the Archer system. So here, as the text says, the home file systems are available logins nodes only, and they're regularly backed up. So the idea is that that's a secure place to store critical source code and data for ARCHER2 users. We will have in total around a petabyte of full usable home file system space once the full ARCHER2 system comes up. But that's much smaller than the work file system space, so it's not designed for storing large amounts of data long term. If you're familiar with Archer, then the configuration of directories and between the home and work file systems is exactly the same as you see on Archer. If you're not familiar with Archer, you'll see that the idea here is that directories are structured under this idea of the file system name, so home in this example here, and project ID, user ID. And so projects are what you sign up for to get access to the system. And we have this idea of this, for example, here there's a user account in home/T01/001/username. Actually, when we go into the system, it will be home/DA004/DA04/ the name of the directory. And this is exactly the same for the work file system. So it's instead of /home, it's /work, but then exactly the same thing. Yes, okay. Quite often, projects will split up these into subprojects so that you could have different subprojects inside the main project. We don't need to worry about that for the accounts we're using today, but that's the way the file systems are configured. And as I said, exactly the same for work, so /work/ etc. etc. So when we submit any jobs, we're going to be in here, and actually it will be something more like my account on here will be something more like work slash TA004, TA004, and then I will call my account something like Adrian J. And so when we go onto the actual system, then this is the kind of thing we'll be using. And as I say, it's going to be much more simple if we just, as soon as we log in, change into this Workfile system and run from there. Workfile system, as I said, is not backed up, so it's important to stress this. It's not backed up, so any data you do leave there long term may disappear if something happens to the file system. And it is much bigger than that home file system. So when we have the full ARCHER2 system, there'll be about 15 petabytes of space there, split up across all the users and all the projects in the system. The work file system is a Lustre file system, so this is one of the common high-performance file systems that are used in HPC, and it will let you you can look up the kind of storage you have on the work file system using this command lfs quota. So if you want to see how much storage space you're currently using and how much storage space you have, you can use this lfs quota command. Instead of saying, well, okay, so it needs to be slightly updated in the notes here. But effectively what you say is LFS, which is the command to do a Lustre file system operation. You're telling it to look at the quota. You want to have a human readable, that's what the H means, and look for group here, T01. And here the command says /fs3, but actually that should be /work. And so that produces will tell you, okay, for your file system work, you've used 17 terabytes of storage and you've got 21 terabytes left. You've used 6 million files and you've got a limit of 10 million files or 100 million files, depending on how many zeros are there, which I can't easily count. And so you can use this to have a look for how much space you have on the system. Now, I think at the moment, we're not going to do anything that needs large amounts of space. Going forward, if you're an Archer user, the amount of quota you have on these file systems is controlled through the projects, and you can access that data through safe, which we'll go on to about later in the course. Okay, it's not something you should have to do for this course, but if you are interested, or if you need to use that kind of stuff, then you can check a lot of stuff about the Lustre file system. And if you were going to do some kind of performance optimization for your applications, you may care then about striping of files across the Lustre file system and all sorts of things. So that's slightly beyond what we need to cover in this course, but there are performance implications of some of the things you can do with Lustre which can improve application I/O. As I say, there will be this solid state storage, but we don't have it yet. The idea is it's going to be faster, but it's much smaller than the work file system. So again, it's about one petabyte of data storage, and it's designed to be there to be used probably by applications that are running. So most of the time your data is on work, but when you run an application, you can copy it across to this solid state storage, and then copy it back again as required. The other thing that we generally set up, just like on Archer, but this is for ARCHER2 as well, within the home and work file systems, is a place to share data or share applications and share files between users. That can be quite useful. So there's these shared directories that are set up both on the work and the home file system. And there's actually generally going to be two of them. One in the top level, so in the sub-project level here, you can see work/T01/T01 shared. And then anybody who's a member of this T01 sub-project here can potentially see data in that shared files in that shared directory. So the example here is I want to create a directory from my subproject shared directory, copy some data in it, change the permissions so people can read that data, and that will let other users see it. And then if you wanted to share data or files between projects, between users in different projects on Archer, there's also a shared directory one level down. So you can see here /work/d01/shared. You do exactly the same thing, but here now people from a different project can also see that if you wanted to share it. Quite often it can be useful if you're having problems on the system and you need to debug it with a member of the Archer team. It's a way of sharing your application or your data as well. And that's true on both the work file system and the home file system. That can be a useful way of sharing data. Okay, and so that's the hardware side. We have these compute nodes, we have a large number of them, we have a lot of cores per node, we have a reasonable amount of memory, and we have a number of file systems all connected together with a high performance interconnect to give you good performance. But of course, the other side of any kind of work here is the software side. And so this is a Cray system. So we have a Cray software stack. It has changed quite a bit from what we had in Archer for a number of reasons. But Cray have sort of upgraded their software deployment for these new systems. And we're moving away from the Intel processors. So the big difference is if you're an Archer user, you'll probably end up seeing is that we have a different set of compilers here than we had on Archer. We have on Archer. We still have the GCC compilers, the GNU compilers, GCC and G-Fortran. We still have the Cray compilers, but now instead of the Intel compilers, we have the AMD compilers as well. So AMD, AOCC compilers. We have the standard Cray libraries, so Cray MPI, which also supports shared memory, OpenSHMEM, and global arrays, and the standard numerical libraries here, where we've got mathematical and parallelical libraries supported through Cray libsci, and now instead of Intel MKL, we have AMD, some AMD libraries there. But the Cray libsci will do the majority of what these AMD do as well. So that's one we can use, which is the same as with Archer. And then there's the FFTW and NetCDF, libraries and others before. Now, we don't, because this is early stage of the ARCHER2 cabinet system, we're still only in early user access mode. Not everything has been installed yet. So these standard libraries will be there. You may not have quite as many libraries as we have on Archer or software as we have on Archer installed yet, because we're working our way through getting this stuff to be ready for a full user access. So some of the libraries you rely on Archer may not quite be there yet. It's a question of getting on and seeing, and then if they're not, putting in requests to check that they will be installed. There's a bunch of debugging and profiling tools. Some are similar to what we had on the Archer system. The ones that's really missing, the difference between the two is we don't have any of this sort of a linear debugger or profiler anymore. So we don't have PPT or map anymore, but we have some standard ones, so Valgrind, CrayPat, GDB, HPC, these kind of things. And there is now much more of a packaged Python setup as well. So Cray now provide a packaged Python setup for Python 3 and a packaged R setup for the system to allow these kind of languages to more efficiently use the ARCHER2 system. So, as I said, the big differences you will be seeing between Archer and ARCHER2, if you're an existing Archer user, is we no longer have the Intel compilers or the MKL libraries. We now have the ARM compilers and the ARM libraries. Sorry, not AMD compilers and the AMD libraries. Apologies for that. And there's there should be a more optimized Python and R setup than was available on the ARC system. And we've lost Forge. We don't have a DDT debugger and map profiler, but we still have CREPAT and other debuggers. And then, as with other systems, we are just like Archer or our Cirrus system, we are installing a bunch of applications for you to use as default as system installed applications, from things like CASTEP to VASP, Grumx to OpenFOAM, and some of these other software tools. Now, again, as I said, not all of these will be fully installed yet. So, for instance, I know Eigen's not installed yet. I've not installed it, and so some of these libraries are not quite there yet, but will be there by the time we go into full Archer service, even for the full Archer cabinet service. But the idea is that we will install, or we have installed for you, a large number of heavily used applications on Archer, and those will be installed and maintained by us, by the people who are running Archer. But then beyond that, it's your responsibility to compile and install other things that you need. Obviously, we're there to give you help, but we won't install everything centrally for you. Yeah, okay. And so, as we should see when we go into the system and we come onto the later lectures, we're using the module system here. So this is all available through the module command, which we'll want to see. If that makes no sense, you don't worry, we'll have some examples of that. It is possible to also bring applications on which require a license server. So we have license servers that are available, and there are ways for us to connect to remote or local licenses. If that's the kind of application you have. Most people, this is not an issue for, but sometimes people require commercial software, or companies need to bring in their software onto it. So that is possible. If you need to do anything like that, you get in touch with us and have a chat. And the other thing that we will be supporting, but again is not quite there yet, is containerization. So running containers on ARCHER2. The current plan is to support Singularity. Singularity is one of the performance computing container approaches, a bit like Docker. It builds on Docker in some ways, but it's optimized and secured for HPC systems. So there will be expectation that you should be able to run Singularity containers on ARCHER2 once we're up and running. Again, we're not quite there yet, so it's not something we can play around with today. But it will be one of the mechanisms for running your applications on Archer. And again, that should mean that you can compile and run software on ARCHER2, which would have been hard to do in the past because it requires different versions of operating systems or different configurations of systems than we provide, which may be useful for you. Of course, the devil is always in the detail with these kind of containerization solutions. In fact, making sure you get access to the performance network and the high performance file systems properly will be require a little bit of care. But it's something that should have guidance on in the Archer documentation as soon as we get to a point where we can deploy them. These contain on ARCHER2. Okay, so any questions about that? As I say, now would be a good time to make sure you're signed up for the Archer accounts if you want to use a system. If you don't just want to hear me chatting about it, but if you want to actually get on and use the system, now would be a good time to make sure that you've signed up through the Safe system for an account on ARCHER2, and I can approve that for you so that we can get you on the system. Yeah, so as we summarize down here, ARCHER2 consists of high-performance login nodes, compute nodes, storage system, and interconnect. There's a wide range of software available on ARCHER2, although for some applications you may have to build and install your own software. We can help with that. And it's a standard-based Linux-based system with command line access. So we're SSHing, copying files across to it, and we're running on a batch system. Okay. Well, what I'm going to do now is going to take a break. So we're running slightly ahead of schedule. I'm going to take a break now here for 45 minutes, actually. We'll restart at 11:30. We'll talk about connecting to ARCHER2 and transferring data. But what I want you to do in the meantime is what we're going to do is I would like you to be able to be in a position when we get to this point that you can log on to a system. And so that means that you need to have signed up and got an account on the system in a sense, and then you should be able to SSH onto the system, get access. And so now would be a good time to go and sign up for that account and then try getting access to the system using SSH. And because we're running ARCHER2 in quite a secure method, just like we're running Archer, it requires you to access the system not just using a password, but a password and an SSH key. And so you need to generate an SSH key and upload that as well. If you're not an existing Archer user, that may take you a little bit of time. So what I'm going to do is stop lecturing now, but be available for you if you have any questions about how to sign up for an account or any questions on how to generate the SSH key or upload it or access the system. But ideally, when we come back at 11:30, it would be nice to for you all to be in a position where you can open up a terminal and actually access to the system. Let me just see if I can share what that should look like. Here we go. So let me just share my screen here. Stop sharing. This one here. So ideally, when we come back to 11:30, you should all be able to access the ARCHER2 system where you can SSH in, and you can get a command prompt like this, where you can see this lovely ASCII art image that's been created. But more importantly, you get a terminal down here on something called UAN01, and we can see that you have access to the system. And then from that point, we can start doing some of the exercises. So do use this chance to ask any questions if you're having a problem getting on. As I say, when you apply for an account, I need to approve it. So it may take a little bit of time to get you on there. But now is a great time to get up and running. Any questions? Yeah. Do ask.
Adrian, what if I want to do something like Xterm or is it GNOME terminal? What is a sort of a new terminal window on ARCHER2? Which one is sort of recommended?
So, would you want to create multiple windows from the same SSH?
Absolutely, yes.
That is a good question. Off the top of my head, I don't know, but I can check. With it. Generally, what I do is just create multiple SSH sessions where I have
yeah, well, right. I can see that Xterm is not available. and GNOME terminal is not available either. So rather than running the multiple SSH, I would rather use the X forwarding.
So X forwarding should definitely work, but
Yeah, it does. I checked it. Emacs is fine, but what about several terminals?
that is a good question. I don't know off the top of my head, but I will have a check for you and see what if anything is supported there. Let me have a look and I'll get back to you.
Okay, so we got 40 minutes break. Thanks.
Yep, no worries.
Hi, Adrian. Can you hear me?
Kevin.
Grand. I've got a bunch of questions for you.
Oh.
The last thing you described was that there was storage systems available in ARCHER2. Is that ultimately, is there going to be an RDF-like system for all users?
That's a good question and slightly above my pay grade. My understanding is that I think there will definitely be. I think there's going to be something that's called the RDF as a service, which will be available to users, but I don't know the details of that at the moment.
And do you know, the RDF and Archer will both be switched off at the same time, is that right? Or will the RDF persist a little?
Again, that's a good question. I'm not sure I know the answer to. I'd have to check and get back to you on that. I mean, I know the RDF is going to be available whilst, during an overlap period between the ARCHER2 and Archer, because obviously Archer's not being switched off yet. How long that overlap period is, I don't know. So again, I'll check and let you know.
I've managed to log on to ARCHER2. I'm such a geek. It's such a thrill just to get a prompt. So it looks like am I right in saying that an entire node? No. How many nodes are you using for login nodes? That's my question.
Well, okay, I think there are 3 login nodes, I think. But probably at the moment we're all using the same login node. I think in this early access period, I think it's not sharing. So on the Archer system we have, I think, 8 login nodes, and you sort of get assigned to them as you log in. At the moment, I think we've got 3 login nodes, but we're only probably using 1 of them at the moment.
Sure. And ultimately, will there always be 3 login nodes, or is that number going to increase?
That's a good question. I probably do know the answer to that, but I need to look it up. Let me have a check in the architecture document. The reality is that the login nodes should be sort of quite well policed nowadays, and that I think we're going to be using C groups and things like that to stop people over exploiting the hardware there. So there should be, whatever number we have, there should be a reasonable resource there. Okay, I think in the ultimate system there's going to be 4 login nodes.
Okay.
From what I can see. And they're just like the compute nodes, and I think they're going to be, I think they're large memory compute nodes, so they're going to be 4 login nodes, each with 128 cores, each with 512 gigabytes of memory.
Okay, cool.
That was actually a question I could answer.
I think you're probably going to cover this later. Just tell me, you don't have to answer it if so. You mentioned the solid state stuff, and jobs can use this, and then data is moved off to work after the job is complete. Who's responsible for moving that job? Is it the user, or is this done automatically?
Oh, so that is still to be debated because we don't have the hardware yet, and it's not configured. it is possible that we can get the batch system to do it automatically. So the batch system we're using in Slurm has the ability to do this sort of burst buffer plugin where you can tell it to stage data in and out. Whether we choose to set it up that way or not, or it's not going to be me who chooses. Whether the service decides to set it up like that or not is a question which is still got to be answered. I mean, there's a couple of ways you could do it. One is you have it as this sort of burst buffer approach. The other could just be that you give all projects a small amount on it and they do what they want with it. So it's yet to be decided, I think.
Mm-hmm. Okay. And one last one before I go off for a coffee. You mentioned that jobs submitted from the home directory won't run and there's no error message. Is that going to change?
No, so that won't change. I think my hope is that we're going to put in so it's possible that our systems team can add a bit of functionality in when you submit a job, which tells you if this happens, right? So effectively the ultimate pre-job submit hook in Slurm and say, oh, oops, you've submitted from home directory. Did you mean to do this? This will fail. It's just a way that the hardware set up, the way the job scheduler works, Slurm works, is different from what we used to have on Archer PBS. And so what it actually does is it uses the compute node to stage the jobs. Because the compute node can't see the home file system, it just can't produce the error file at all. So it's just a limitation of the batch system. But I think, yeah, we certainly discussed it. I can't promise it, but I hope that it'll just be better error message. So when you submit, it just says, look, don't do this. You can't submit this job because you're in the wrong place. It's slightly complicated, but actually, if you really do configure your script exactly in the right way, it's sort of possible to submit from the whole file system, but you still never get any output there. You have to put your output on the work file system as well. So it's sort of a bit pointless. You can sort of do it.
So I might get the terminology wrong here, but on Archer there was a login node, and when you submitted a batch job, the executable lines were run on a node that wasn't a compute node. I think it was a NOM.
NOM node, yeah. No, we don't have those anymore. So now the first node in your batch job, so the first node that's assigned to your batch job does the work of a MOM node now. There's no longer these different set of MOM nodes. It's all just run off a compute node.
So on Archer, NOM nodes were free. No, that's not true. No, okay, forget it.
Well, they were free, but in reality you weren't meant to, as a good citizen, run much on them because they were a sort of shared resource. They were just like the login nodes. In practice, from your job, you shouldn't really see any difference here, I don't think. But
just thinking about, say, a workflow where in your batch script you have an executable running on hundreds of nodes. You then do some basic data analysis, and then you launch another MPI job on hundreds of nodes. And so that basic data analysis. Oh no, there are data analysis nodes. Okay,
yeah, but
I'm getting ahead of myself.
That workflow in a single batch job, and that bit in the middle where you're not using the hundreds of nodes, instead of running on the MOM node, would run on the first compute node in your hundreds of nodes. But in reality, it's sort of no different in the sense that if you do that all inside a single batch job, even on Archer, those hundreds of nodes are sitting doing nothing whilst you wait for the MOM node to do something.
Yes, but you're paying for those hundreds of nodes to sit and do nothing, of course.
Exactly, and you're doing the same here, except one of them is going to be doing something, but it's the same kind of. It's the same kind of.
Okay. All right, I've got other questions, but I'll just wait.
Okay, no worries, Gary. No worries.
All right, thank you.
Okay, so we'll get started again. I've now approved quite a number of accounts on the ARCHER2 system, so I think we should be around about the scenario where most people have an access to the system. But as we're going through the rest of the material. If you try to get onto the system, it doesn't work, you let us know, either in the chat or just shout at me and we'll get that sorted out. Either myself or Kevin or others can help you with that. Because as I say, there's a couple of bits and pieces where we want you to submit a job or compile a code or try logging in, all these kind of things. So it would be useful for you to have access and to run through some of the examples yourselves so that it's clear what we're talking about. So let me just share my correct screen again. My Chrome is not responding. Let me try it again. Apologies for that. My Chrome session just decided it wasn't going to work. So let me try that again. There we go. So next, we're going to quickly, hopefully, look at there it comes up, connecting to ARCHER2, and then the software environment on ARCHER2 is the plan next. As I was saying before, hopefully you've all managed to connect and got access. We'll see as we go along. So ARCHER2, just like any of the HPC systems you'll have access to, is accessible over SSH, so it's secure shell access, and it's an external system where, as we've already discussed, you log into the login nodes and run your jobs from there. The address for ARCHER2 is login.archer2.ac.uk. Very imaginative. And just like with the current ARCHER system, and particularly based on the security issues we had earlier in the year, we now run this sort of two-factor or two authentication mechanism for accessing the system. So you need a password, which you should hopefully be able to get from the safe site, and an SSH key, so a password protected SSH key pair, which you can upload the public key for on the safe site as well. And this is, even I find this slightly annoying, having to go through these extra hoops to secure access to the system, but unfortunately that's what we need to do at the moment to make sure the access is secure. And so if you have any problems either getting your password for a login account or uploading your key and using your key, please do let us know, because we do realize it's a nasty piece of functionality to get used to, or to get to deploy when you first have to use it. Generating SSH keys and uploading them is a little bit tricky and has kept us busy for a while with users on ARCHER and other systems. Let me see what the question is. Could I make the font a little bit here? Yes, definitely can make the font a little bit bigger, Kevin. 1 second. How's that for you? Or a bigger still? Easy, make it bigger still. It's useful, or something like that. As I say, you don't necessarily need to go, as I've said, you don't necessarily need to go through this. The website is in the chat for you if that's useful as well. So there we go. So we have a specific password policy on Archer, which is reasonably complex and not my favorite thing. But it's outlined here at this link here. And actually, if I open this up now, you can have a look through it, which may be of interest to you at some point, because sometimes you have to change a password or create a password, and it's useful to know what the requirements are for that. The sensible ones are straightforward ones is what I meant to say. Straightforward ones are you're not allowed multiple characters of the same type. You're not allowed dictionary. You're not allowed to use a single word, or 5 characters of a new password must not be present in the old password. Passwords have to have a minimum length of somewhere between 10 and 16 characters, depending on how you do it. And the sort of more complicated side of this is that there's a whole range of different ways that this is set up. And I think actually this is wrong. I think that needs updated. I don't think the minimum password length is 18. I think the minimum password required credits is 18. And you get credits for using lowercase and uppercase and punctuation and these kind of things. And so I think there's a way that you get. Oh no, okay. I'm talking. Minimum password length is 18, but I guess it removes numbers off that if you use lowercase, uppercase, numeric, and punctuation. So you can get to a password which is the shortest password you could use 10, maybe up to 16 characters in length if you don't use multiple ones of these. So if you only did all lowercase letters, no numbers and no punctuation characters, then your password would have to be 16 characters long. If you were doing lowercase and uppercase and numbers and punctuation characters, then you could have a password which was only 10 characters long. So this is why it's slightly hard to generate an effective password on Archer, because depending on how you configure it, you get different requirements. Anyway, that's the password policy we have. So there's an example here. Which of these 4 passwords would be a good choice according to the ARCHER2 password policy? My password, Rainbow Llama Jumping, this long letter, set of letters and numbers and punctuation characters for horseback Tristan. Actually, interestingly, these kind of passwords is what we always used to have to give out for guest accounts. So we used to set up guest accounts for these courses, which all accounts have the same password because they're only temporary accounts. They were generated for us by the systems team, and they always used to be quite hard to give out to people. Often used zeros and O's and these kind of things. But, yeah, so there's the question here is which one of these would be sensible. So we've got to remember the policies, as you can't really have something which is generally just based on simple dictionary words. We can't, but we can have things which are just all lowercase letters, because as long as it's long enough, and we can have something that's short as long as it's got lowercase and uppercase and numbers and characters in it. But actually, maybe even some passwords which are quite long, which match all the policies, but get rejected because they are commonly used passwords or reusing passwords from before. So the answer here is that for these 4 examples, the first password is not acceptable because it's too short. So it's too short in the sense that it's only, I think, 10 letters. It's not got any of those uppercase, lowercase numbers in it. Rainbow llama jumping is fine because it's all lowercase, but it's long enough. As is this one here, number 3, that's fine because it's enough random different characteristics in it that the password will force you to accept it. And this last one looks like it should be fine, host factory staple, but actually because it's checked against a set of common passwords, it comes from XCDI comic. It's maybe rejected because it's in that list of common passwords. So, this is not going to affect how you run this. You run your jobs or you compile your code or anything like that, but it's just useful to know that when you get access to the system, these are the kind of things you need to consider. When you sign up for an account on Archer, what will happen, and hopefully the process you've been through, is you apply for an account through this safe site, and one account gets set up for you, and you get given an initial password, which you can access through the safe site. And you can use that initial password as a one-time password to get you on the system, and then you have to change your password for something you choose. And that's where these rules come into account, because it can be quite annoying if you use a password which it doesn't accept. You have to go through this process. But hopefully, as I said, I've seen quite a number of requests come into the project over the past half an hour. So hopefully, you've all got signed up to the system, and we can go through that process quite soon. The other side of that is we also require SSH keys to get onto the system. So you have to create a secure shell key with a passcode or password on it, and then use that to access the system. But again, there is a reasonable, long and detailed guidance on how to do this through the Archer documentation. So this is actually something I should have highlighted to begin with. All the stuff I'm talking about today and tomorrow in the course really should be documented as well online in the ARCHER2 documentation system, docs.archer2.ac.uk, where you can go and have a look in more detail at some of the things that we covered today. I'll put our website in the chat as well, because that can be useful. So you need to generate an SSH key and then upload the public part of it onto a safe site so it can be used. And that takes a little bit of time, I think, as well, to copy it across onto the Arch system, so it may take a couple of minutes between when you upload it and when it allows you onto the system. So if you're struggling to get access just now, then have a look through this SSH guide and see if you follow the steps in here. If not, let us know what's going wrong, and we will help you with that. Okay, so that's just accessing system. Once we're on the system, then we have different ways you can copy data in and out, but because again it's a secure system, just like Archer, then we would expect you to be using, or you need to be using things which can work with these secure access methods. So SCP, which is a secure copy, you want to transfer data to and from Archer. If you're talking about small amounts of data, small numbers of data, SCP is a sensible thing. Or rsync, and actually rsync is probably more functional than SCP because you can use it to only transfer new files and these kind of things. And at some point, although we're not quite there yet, Globus Online should be enabled on this system as well. Again, documentation has the documentation website has details of data management and how we can transfer data on and off the system here, and how we can transfer bottom SCP, exactly how you do that, rsync, and these kind of things as well, and Globus Online. It's not quite there yet, but once the system's up and running as a full service, definitely will be. So if you have any questions about that during today and tomorrow, that's also, do let us know. Particularly tomorrow, if you're doing your own applications, you may want to be able to transfer data on yourselves tomorrow. Alongside so there's a couple of things that we need to care about with data, which you've already talked about. One being the preservation of your data, so the home file system is backed up, and the work file system is not backed up. So if there's data that you really need to have safe whilst you're running on Archer, then home would where you want to be, and copying it to and from the work file system whilst you're doing that is a sensible thing to do. And then if you're wanting to transfer data to and from Archer, then you need to understand that there are different ways you can do that. And so actually the performance you get when you transfer data on and off a system like ARCHER2 depends not only on the amount of data you need to transfer, so, which is sort of governed by the bandwidth between the system and where you're trying to transfer to, but also the number of files that you're going to send. So you've got to send lots of little files that can really take a lot longer than one big file, even if the overall amount of data you're transferring is about the same, because there's an overhead for getting a file and setting up a connection and transferring that data. So each file has an overhead in transfer. So if we're going to transfer large numbers of files between systems, it's probably sensible to group them up into one big file if we can, into an archive. So using a tar or zip to put them in there, and transfer that archive file across. And then there's the question of whether you would want to encrypt your files, so not encrypt your files, whether you want to compress your files when you're transferring them across, and that may be beneficial and it may not be. So actually it may be that a lot of the data, if you're sending large binary files between the systems, it may be that the compression doesn't really improve file size very much. It tends to be well for large text files or regular files. Large data sets may not compress hugely, so maybe the time spent compressing those files is not beneficial. And then the final thing you may care about is encryption overhead. So one of the reasons that copying files between systems can be slow is we're copying over a secure setup. So the SCP or the rsync is having to do some encryption and decryption to move files. And so that encryption decryption overhead is generally on a per file basis. So that's one of the reasons why having large numbers of files is problematic for performance. But you can also change the encryption algorithm to maybe reduce the amount of encryption done, and particularly if the files are not particularly confidential or sorry, apologies. Okay, can you hear me now? Okay, apologies for that. Where did I drop out? Did I drop out at saying discussing the creating a uncompressed this example here, or was it before that? Did I? Okay, fine. Apologies. Okay, so let's go back. Good job. We've got a lot of time built into the schedule. So yes, there's a couple of different things you could also consider if you transferring large amounts of data, and it's going to take a long time. There's a couple of other things you could consider for optimization. One is compressing the files. So if they're large, sparse files, it may be that compression makes them much smaller. For a lot of binary files, that might not be the case. It may be that compression doesn't really help. So there's a trade-off between compressing files to transfer or not, particularly in the time it takes to do the compression. And so that's one thing to consider. And then the other thing is the encryption overhead. So because one of the reasons that transferring large amounts of small files takes a long time is we're using secure encryption, secure transfer techniques. So things like SCP and rsync are going to set up an encrypted communication, and that takes some time. But there are ways you can reduce that overhead, particularly using a faster encryption algorithm may give you some benefits there. So if these are the kind of things, if you're running into large overheads transferring data to ARCHER2 or from ARCHER2, these are the kind of things we need to consider. Now, of course, we're not going to run into those problems today and the examples we're looking at, but we may run into them. You may run into them if you're a user coming onto a system, or indeed even transferring data from ARCHER2. So ARCHER to ARCHER2 is in the same, it's sort of in the same data center. The connection should be reasonably good. I've seen sort of estimates of 50, 60, 70 megabytes a second, but it's not. If you've got a large amount of data to transfer between them, that still may take a long time. So it's worth considering some of these aspects. And then there is a final exercise that you could do here, which is using the documentation above, find the command you would use to create an uncompressed zip file of all the data within a directory called large output. What command would you use to verify the archive file you've created is not corrupted, so you can safely delete the original data? And really what we're asking you to do here is go and have a look at the documentation and see if you can find out the bits to discuss how you create uncompressed zip archive files and how you verify the archive file. So that's quite an important step to ensure that your data has been transferred across correctly. So take a couple of minutes, go and have a look at that, and then we'll move on to some more practical side of this course, which is looking at the software environment on ARCHER2 and compiling and these kind of things. Okay, so I'll pause there for a couple of minutes. If you've got still having any problems connecting to Archer or with the account stuff, you can ask me now as well, because that's a sensible time to do. Okay, so I've just had a couple of quick questions from people who are not managing to access the system at the moment, and so we'll work through those. Don't you worry, we'll get you up and running on ARCHER2. As I say, this two-stage having to do the SSH key and then the password is quite complicated, particularly if you've not been through it before. So it can be a problem. And don't worry, because if you are trying to access, if you can't get on now, but we managed to get you on later, this recording of this session will be made available, and the website is still there for you to work through at your own leisure, and you can get in touch with me outside this time as well if you had any questions. I'll put my email in here just so you know it if you have any questions. There's also an interesting question about this two-factor authentication, and then how do you copy files between different systems, because SCP or rsync also requires connection to be made with both the SSH password and your key, your SSH key that you prepare. So it may be that you need to forward key authentication or access to an SSH key proxy or something like that, which makes it easier to hold the SSH key. Well, the problem is that there's lots of different ways of doing this, as Claire can attest to. There's lots of different ways of doing this, depending on how what you're accessing from. If you're coming from Windows, if you're coming from Linux, if you're coming from the Mac, and generally you need to pass in a path to an SSH key or forward that SSH key back to some kind of key holder. Yeah, okay, so good question. So Mike, you said I seem to be logging in without being asked for my key passphrase. When you set the SSH key, you don't have to put a passphrase in. It's good practice to put a passphrase in. We would suggest, strongly suggest that you should. But if you create an SSH key without the passphrase, then you can use it without putting it in. So it may be that your SSH key, Mike, has not got a passphrase on it.
No, it does have.
Oh, okay. Okay, fine. Fair enough. I'm surprised, Ben. I mean, so what I do, if I'm on Windows, is I load my SSH key into an authentication agent and put in my password there once, and then it doesn't ask me again whilst that authentication agent is running. It could be your agent is asking it, or it could be what Kevin says, that it asks for your machine password first and then your SSH.
I'm using Linux. Did SSH add, entered my passphrase, and then SSH'd onto Archer and was asked for my password. And
okay, yeah. So that SSH add bit is setting up the key agent, which will hold it open as long as that your session is open. That will hold the password for you, so you should be able to reuse it between multiple SSH sessions.
Thank you. So that bit happens on my machine rather than.
Yes.
Thank you. I remembered that. Silly. Thanks very much.
No worries. Okay, so we will come back to. There's still a couple of people with outstanding issues, which we will come back to as we go through this session. Don't worry about it. We will get you on the system. But just to wrap up what we were talking about there, the solution to this is that we can use this zip command, and then we can tell it to not compress the data. So this comes back to this idea of actually taking a large amount of files and compress them take a long time. So if the compression doesn't help me, I can use this zip command with -0 and recursive and create it. Then you can use the zip -t to check that the archive is valid. So that will let you pass a lot of these kind of data. So if you're moving large amounts of data, these kind of options can be useful to you. Good. Right, so then what we'll move on to then is the software environment on Archer. And then I'm going to, for those of you who've not managed to connect yet, I'm going to also share one of my terminal screens so you can see what it should look like. And as I say, we'll work on getting you onto the system as well. So let me just change the appearance of my screen so the font is bigger. There we go. And then this is going to involve me switching between different screens to display in this session. So if it falls over, apologies. I'll just connect back in. Let's hope that it all works fine. So just like on Archer, we're using environment modules to provide access to different versions of software on the system. These modules and versions will change through the lifetime of the system. So this is no different from Archer, current Archer service, or any other HPC system, or many other HPC systems like the Cirrus one we run here. And this is the way we're going to access the compilers, and we're going to access any other third-party software which is installed on the system. So some of those applications we talked about before. Particularly when you first log into the system, you get a default environment. And so this is an example here where we get the Cray compiler environment, Cray MPI libraries, Cray libsci and numerical libraries, and some modules to enable you to access the system. So when you first log on, you should be able to see something that looks like this web page here, but let me share my, share my screen. Application window, I think it's going to be this one. There we go. And so if I type this command module, in fact, let me clear this. So I type this command module, and then I type this command list. I've not done anything at all for this account when I've logged in. I've just logged in, and you can see I've got a number of things that are already set up for my application, for my terminal. The ones that are particularly of interest to me here are, this here is the Cray compiler. And then we have the Cray MPI library, which is the default one you'll use. Cray libsci, which is maths libraries from Cray. And then, as it said in the slides, some basic performance tools are also loaded. And we have also this sort of generic environment set up here as well. So far so good. We've logged in. We have a set of modules already loaded. We can then use. So I can then change what the modules are loaded. So if I type module avail, it stands for module available. It'll tell me the other things that have been installed on the system. Now, as I said before, we haven't installed everything that will be there when the final system is up and running. But there's a reasonable amount of software in here. You can see things like here, there's a Cray Python 3.8.5 library. So as I said before, the Cray optimized Python library is in there. There's global arrays. There's a bunch of applications here. So CodeSaturn, CP2K, GrowMax, LAMPS, NAMD, Help, OpenFOAM. There are more coming and more will be available. There are also other things like the Open MPI library. So theoretically, although I've not tried it myself yet, it's possible to use other MPI libraries on this Archer. Some some little tools like XTHI, which we'll use, XLIS, TensorFlow, Torch. So you can start to see that there's a set of environments and software already set up on the system. One of the important sets here are these programming environments. So here we've got something called CPE AOCC, CPE Cray, and CPE GNU. So these are the different compilers we have available on ARCHER2. The GNU compilers, GCC and GFortran, the Cray compilers, Cray FTN and Cray CC, and the AOCC compilers. And so this is very similar to what we had on Archer. In Archer, we have the Intel compilers, the GNU compilers, and the Cray compilers as well. So that's what's available. I can do sort of different things with module commands. If you're not familiar with module, I can have a look what I have there. I can have a look at what different versions of the Cray libsci libraries available. There's only one of them available. Let me see if I can find something where I can swap them. So I've got a module for, let's try DevTools. This. Nope, there's only one of them available. What I'd quite like to do is find one where there's multiple versions of the same. Okay, we can try this one here. Create huge pages. So if I say module there, create huge pages, will this work? Yeah. So there's a whole bunch of modules which we don't need to worry too much about, but for setting up default page sizes for application, this can actually impact performance for some applications. And by default, let me have a look. Is any of them loaded? No, so none of them is loaded. So if I wanted to add a new module here, so I say module load, grapey, huge pages, 2 megabytes. I've loaded that module. If now I do a module list, we can see I've got another module loaded here. And what this has done is it's set up the environment variables associated with this package so I can use it properly on the system. Actually, it doesn't do it anything magic. It just exports a whole bunch of environment variables, because you can see what it's doing. Actually, if you do module show creepy, and it can tell you, well, you can't load it with these modules. And if you do load it, it adds these environment variables in. It adds these things into the various paths. So that's all it's doing. But if I wanted a different version of that module, as I've said, we haven't got loads of different modules available. I could use this module swap command. What module swap creepy huge pages to M to say create the huge pages 1G. Now if I list what I've got, you can see I've got the different huge pages. So I can change these, I can unload, I can do a module load, add a module, I can do a module unload, remove a module. I can also do a module purge, and that will set me up, I'll get rid of all the modules that I had set up when I first logged into the system, which is probably not what I wanted to do. You can see I've now got no modules available. And if I type module now load, I can now set up a new programming environment. So I can say, okay, give me back the Cray programming environment. Here we use this prog env Cray, which is the one that's well, that's embarrassing, isn't it? So, okay, let me try this again. Let me try this first. Module load. Let me try module load CPE. Okay. Right, so this is one of the differences that we have between the Archer and the ARCHER system, is that on Archer, I could have done module load prog env. That says load the programming environment for Cray. So that means set up the compilers and all this sort of these libraries that I need to program with the Cray compilers. And I could have done the same module load prog env GNU. The way that this is done now in ARCHER2 is slightly different, and it turns out that this group of things, the programming environment for Cray or for GNU or for indeed module load programming environment AOCC, is now no longer a module. It's now what we call a collection of modules. And so to get it, what I need to do is do a module restore instead. I think I mean, very impressive when this doesn't work, but module restore, prog env Cray, module restore the programming environment, will then set me back up where I was before I did my module purge. Let's try that again. I started off, I've logged into the system, I'm set up with the Cray programming environment. This is what it looks like. Most of this you don't need to care about, but it gives us access to Cray compilers, API libraries, all those kind of things. Then if I do a module purge, which you never usually need to do, we can see that got rid of all my modules. If I module restore, Cray, you can see now I've come back to a place where I started from. So the way that we access the compilers on ARCHER2 is similar to Archer, but slightly different, unfortunately. Let's have a look. Okay, so great question. Great question, Gavin. How do we then move between compilers? So here I'm on the Cray compilers, but it could well be you want to use the GNU compilers. So here what I do then is module store prog and GNU. You see what it does, it goes through, it unloads all the things I had loaded, and then it reloads in a new list of things. So now we can see that module restore programming environment GNU has installed for me the GCC 10 compiler by default and CPE GNU. And then everything else looks pretty similar, but it's installed the programming environment. So the way we switch between compilers and Archer is this module restore command, module restore. And I can also then switch to the AOCC, the AMD compilers as well. It does the same thing. The only thing to note here is this looks similar to what we do on Archer, but we're using restore instead of swap or switch or load. And the slightly annoying thing about it is when you do a module restore, it gets rid of anything you've already loaded. So if I had loaded that huge pages module because I wanted it, and then I swapped to a new programming environment, so I swapped between Cray and GNU programming environments, I would then have to reload manually that huge pages module because it gives my environment back to this 12 set of packages and it's got rid of anything else. So if you're using libraries and you restore to switch to a new compiler, you have to reload those modules when you do it, unfortunately. That's annoying the way it's set up, but that's just the way the module collections work, I'm afraid. As we go on. Okay, so there's a question here. Is there a warning about not unusing certain modules important? No, I don't think it is. So I think the warning here, so it says warning, did not unuse opt-cray module files. All it means there is that you may have, there may be modules available for you to load which are not compiled necessarily with your current compiler, but the modules themselves that you're loading should be built in such a way which they'll tell you if that happens. So you can ignore this warning, did not unuse line here, as Kevin says. Right, I've gone slightly off piste here, I think. Yes, okay, so another good question from Kevin. ProgEnv AOCC uses Cray libsci rather than AMD AOCL. Correct, at the moment, no, but by default for all the installs, all the programming environments on Archer, the default maths library is Cray's libsci. Okay, so we do have the AMD libraries installed on Archer as well, but the default is Cray libsci. You can unload that module and load in the AMD libraries instead if you want. Just like you could have, yes, you could have. It's slightly different to Archer in that on Archer you would have had when you load the Intel module, you probably get MKL by default. But on the AMD one, we have the Cray libsci. Well, it's a good question. The reason is this is how Cray bundles up these modules for us. Does Cray outperform AMD? I've not done enough performance analysis to give you a good answer to that. What I've seen for standard BLAS kernels, standard maths library kernels, is that they give similar performance. The AMD one may be slightly improved. The AMD one doesn't necessarily nicely link in with ScalaPack and some of the parallel stuff that libsci does. So I think that's why the Cray one is the default, because it is more functional in terms of some of the wider operations it can support. There's nothing to stop you changing that, of course, yourself. And let me see, can I tell you what the AMD maths libraries are called as modules here. It could be that they're not fully installed as modules yet. Let me have a quick look. As I say, just because we're at the beginning of the system, not everything is here yet. So I'm not sure that the Cray the AMD maths libraries are fully installed as modules yet. but I could be wrong. So let me just check. So one of the ways we can check what's inside a module is if I did a module show PEAOCC, no module. I just want to see what's inside the AOCC module. Okay, so the AOCC module gives you the AMD compilers here and the AMD libraries. And so we could have a look here what is in the AMD library configuration. And so I think some of the, it doesn't look to me like we've fully installed all the AMD performance libraries for users yet. But if Kevin knows better, he can correct me if I'm wrong. And so, yeah, but I should have actually done, if I did a module restore prog and GNU, back to the GNU compilers, you can see in my environment here, I've got the GCC 10 compiler installed by default. But there are other versions of GCC available. So at the moment, we've got GCC 8.1, 9.3, and 10.1. So if you wanted to run with a slightly older version of GCC, you could do a module, after you've done your module restore, you could do a module swap, GCC 8.1.0, for instance. And then we could see that we now have the 8.1.0 version of GCC installed. Okay, so Kevin tells me that's a bad example. Use GCC 8.1. Certainly 10.1.0 and 9.3 are fully set up as far as I know. I can swap say to a 9.3.0 library and say GCC version. As time goes by, we expect these compiler versions to change. So if there's new GCC versions available in the future, they'll get installed, and then maybe over time some of the older ones will get removed. So that's how the system will evolve over time. Right, let me just switch to the lesson. So again, this is where my collaborate may let me down, but let me switch to a Chrome tab. There we go. Okay, so as I've said, you can find out, if you're not familiar with modules, you can find out this module avail command that shows you what's installed. There are some bits of software which may be installed as modules which you can't actually use or you can't see because you need a license or you need to be have joined that project or been added to that bit of software when you join. So things like CastEp and stuff like that need licenses are available on the system, but you may not be able to run because you haven't been added to the group. So you can be added to that group through a safe, you can request access and these kind of things. So there is a bit more complexity there. The module system will tell you a bit more information. So most of these modules, if you do module help, Cray, NetCDF, for instance, it will tell you, what's installed there and how to use it. And as I've already demonstrated, you can list what modules are. You've got it loaded. You can load new modules. You can swap between modules, just like we've been saying. The compilers, with different compilers, you swap between using this module restore. And the annoying thing is this module restore gets rid of all the compiler variants that you had before. All the module that you'd already loaded. So you sort of need to do this first and then load modules into them. And within that programming environment, you can swap to different versions of the compiler, as I've just shown. You can swap GCC to GCC 9.3.0, for instance, and that's the way it works. Now, as with the standard Archer system, the current Archer system, ARCHER2 uses these compiler wrapper scripts. So if you're an Archer user, you'll be very familiar with these. This is why we have these programming environments, because the compiler names we use never change. You always use FTN for the Fortran compiler, a lowercase cc for the C compiler, and uppercase cc for the C++ compiler. But when you switch between those program environments, that programs, you get a different compiler when you invoke these. So I can give you an example of this if I share my screen again. Try this one. So if I have a look, I've now got the GNU programming environment loaded. If I did cc -v, so C compiler, what's my version? I can see I'm using GCC 9.3.0. I switched it. CC, capital C, but that's the C++ compiler. You can see we're also using GCC, and then FTN -v. They're all the GCC compilers. So the GNU compilers, Fortran, C++, C. If I save this, and if I do a module, restore, prog, and free, this. And if I do cc -v, we can see that we're using the Cray Clang version 10.0.3. C++ compiler is the same Cray Clang version. The Fortran compiler is, it's not going to tell me what the version is. It's a Cray Fortran version as well. So you can see that I've used the same names, FTN, capital C, and lowercase c, but I can get the different compilers. Actually, this is a difference on ARCHER2 versus Archer. Cray have now moved to a new version of their C and C++ compilers, built off this open source Clang project rather than being their bespoke C and C++ compilers. So they actually rely on some of the GCC technology and the Clang technology to do these. So you may find probably not a difference in terms of flags you use, but maybe a difference in performance between the C and C++ compilers on ARCHER2 versus Archer. And likewise, if I did a module restore programming environment AOCC, this is now AMD compilers. You can see we're using the AOCC LLVM compiler based on a version of Clang as well. So this is now AMD compilers, and they do something similar to the Cray ones in that they exploit these open source compiler projects, LLVM and Clang, to build their environments. Same with the C++ one and the Fortran one, except the Fortran one as well. So we have these compiler options, and they're configured for you to compile in a sensible way. So you can see in this AMD compiler, they've already, inside the module, has set up for you the flags to give you optimal performance for the processor we're using. So this march equals ZN version 2 is all set up for you. So you shouldn't have to do any of that with any of the compilers. There should be a good configuration for those, with the caveat that the GNU compilers, you generally need to turn some optimization on to give you good performance. Although I think version 10 of the GNU compilers gives you reasonable optimization from the default configurations as well. So the version 10 of a compiler has moved on quite a long way from some of the versions that we tend to use on Archer at the moment. So that's the compiler libraries and compiler wrappers. Let me stop sharing that screen again and start sharing the web page. ARCHER2, so and a change from Archer to ARCHER2. ARCHER2 generally only supports dynamic linking. So what does this mean? It means that when you build your program, there's two ways of doing it: static building or dynamic building. And actually, for most systems, not HPC systems, but if you had Linux on your laptop, or if you had Linux in if you had a Mac system, generally they build in this way that's called dynamic linking. So your program's compiled, but when the executable is set up, any libraries that you use are not copied directly into your application. They're just left where they are, And a link is put in there to say, okay, when you run this, go and have a look in this place for this library and use it when my application runs. It's called dynamic linking. It's good in the sense that it reduces the size of an application. You don't have to bundle everything in, all the libraries into one file, so your overall application size, your executable size is smaller. And if you update the libraries on the system, since you compile that code, you should pick up a new version of the libraries, which a lot of the time is good because you get bug fixes and security fixes by default. Although sometimes it can break your applications because the library might have changed sufficiently since you last compiled your code, but it no longer does what you expected it to. The other mechanism for doing this is called static linking. This is where when you compile your application, any libraries that you use are copied directly into the application and bundled up with it, so it can run by itself. It's standalone. And this is good in means that you can take that file and copy it somewhere else, and you don't have to have access to those same libraries to run. But bad in the sense that the executable needs to be bigger. It's bundling up all the libraries you're using, and you don't get any automatic upgrades of the libraries if they're changed. You have to recompile your program to pick up the new version of your setup. On Archer, current HPC system, the approach was by default everything was built statically, so everything was compiled up and then could run on the back end without any problems because it was all packaged up together. You could get to do dynamic linking by setting special environment flags, but it didn't do it by default. The opposite is true on ARCHER2. So, but on ARCHER2, dynamic linking is done by default. Actually, it's sort of static linking is disabled, and this means that applications, from a programming point of view, from a user point of view, not that much changes if all you're doing is using the standard system libraries and the standard system compilers. It means that when you run on the system, you should be able to generally pick up everything on the compute nodes. But if you're building your application, building libraries yourself, building your application to use those libraries yourself, you probably have to make sure that those libraries are available on the Workfile system when you run your application, so that when your application runs, it can see them. And you may have to set that up inside your job script. So you may have to manually set up a what we would call an LD library path. You may have to manually export the LD library path to say, these are the libraries you'll need at runtime. This is where they are. Okay. And so if that's you, if you're likely to be building applications which require libraries which haven't been centrally installed, then you may need to care about that. And if you don't know how to do that, you should get in touch with us and we can help you with that. Also, the software libraries we're building and installing generally also need to be available in your application job when you run it. So that means that when you write your job script and say you're going to use a module like our say the Eigen library, which you've installed centrally for you to use. Eigen's a bad example actually because it's mainly a header library, but say the GSL library we've installed for you, you probably have to do a module load GSL inside your script so that you get access to that library. So it's all set up when you run your application, not just when you compile, but when you run it as well. This is a slight complexities. I mean, they're generally manageable. We can certainly help with them. It's a slight change from what we did on Archer. And so when you're first porting across, it may require a little bit of playing around to get these things to work properly. But in general, it's more comparable to building on a local system or a standard Linux system, because that's what generally happens. Yes, okay. So what I would actually okay, so Mike's got a great question here. Can I create modules for use by a group? different NetCDF libraries, for example, is there a group usable backed up space for such modules and associated software, right? So there's multiple questions in here. You can definitely create modules for people to use. So what you would do is use this command called module use, and you put in the path to somewhere. So let's say, I'll give you an example in this chat window. If I did that, if I created a module, I installed it in /work/TA004/TA004 shared. I put my module in there somewhere. Sorry, not my module, my library. I built NetCDF. I could say copy it in, create a version in there, create my something like NetCDF 4.2.1 in there. Then I could create a module file in this place, work TA004, TA004 shared module files. I create my own module file in there, and then if I use this command module use and pass the path into where the module files are, that sets it up as a module which I can load. As long as you've set the permissions correctly, anybody in your TA004 project will be able to do that, and be able to use it and load it. Now, is there a group reusable backed up space for such modules and associated software? It's a different question. So definitely on the home file system, you can create a home TA004, TA004 shared. Anything in there, this home file system is shared as long as you set the file permissions correctly and is backed up. Of course, the problem with that is that file system home cannot be seen from the compute nodes. If you wanted to build libraries which could be used inside the applications, you'd also need to put a copy of this on /work as well, but it's not backed up, but is accessible from the compute node. So if you really want this to be backed up, you would need to keep two versions, one where you install it on home, and then copy that install across to work so it can be seen on the compute nodes. And then you could use a module use after the module files, and then you can load those modules in your batch scripts, and that will work perfectly well. Does that answer your question, Mike? Indeed, this is a great thing to do if you are running a project with a group of people and they're all going to use the same software. But it's not something that's been centrally installed. It's very good practice if one person can build it and put it in a place and create a module file for other people to use. That will sort of save a lot of people effort to do that. And you won't have to have 50 different copies of NetCDF. You can just have one copy of it. So it's definitely good practice to do that if you can. Okay, so that is the. Is there any other questions about how we build, compile and build on ARCHER2? Because that is the sort of end of that lesson, but actually we haven't given you any practical experience of doing this yourself here. So what I would quite like you to do actually is, let me have a look. I'm going to put a link into the chat here. Here's a file which we'll actually use later when we're doing some of the profiling stuff, I think, or some of the other stuff later in the talk. But here's an archive. It's a file called embody.par.gz. So this is not actually written up in here, but what I'd quite like you to do is copy that file onto ARCHER2, unpack it, build it, and then try compiling it with the different compilers. And so to get it onto ARCHER2, you should be able to do this command here. You get, that should copy it down onto the file feed. Then you should be able to extract it by doing this command, tar.gz. Then inside there should be a couple of things that you can. There's some code in there. Let me have it. Just look at it myself. Slightly, there's a make file in there, so if you type make, it should build. Now, I've given you slightly the wrong command to do this. Yeah, thank you. So that's correct. That's because my wget command was a little bit malformed. So if I did this instead, if you do your wget command as this instead, you should get it in the right form. Or as Doug has put up here, you may have to move. You may have to run this command here. Move body par.gz raw equals true to nbody par.gz. So copy that down to Archer, unpack it like we've shown you, and then compile it. And then that should give you an application built. And then just try module restore the different prog environments and build it with a different compiler. It doesn't actually have any flags in which you need to change. But just try that and see how you get on. You may have to do a make clean between each make. Put that in here as well. Interestingly, so the AOCC compiler doesn't work by default with this make file. So we may have to hack that to get that. Not hack, sorry, I didn't mean hack. We may have to slightly modify that to be flags. Let me see if I can get fixed. Yeah, okay, that's interesting. So yes, download, compile, try the 3 different programming environments. So module, restore, prog, and cray is the first one, which you should have by default. Restore, prog, and GNU, and then module, restore, prog, and AOCC. In between each of those, you probably want to do make clean and then make. And the AOCC one will break, won't compile. Have a look and see if you can work out how to fix it. And if not, I will tell you in 10 or so minutes, 10, 15 minutes, how I fixed it. It's an easy fix, but you need to change how the compile happens. So have a look at those 3 of us. We won't run it just yet, but it's just a compilation thing, so it shouldn't take you long. Can those of you still having problems accessing, please let me know, and I will help you out to do this. And any questions, just let me know. So I've just approved a couple more accounts. If anybody's still waiting for an account to be approved or haven't signed up yet, do let me know. And if you have any problems getting onto the system or running any of the commands I put in there, let me know. I apologies as well, I forgot to put in, once you unpack the tar file, the tar.gz file, it'll create a new directory which you need to go into. You need to do the cd nbody, which I neglected to put in the list, so apologies. As I say, we're not doing anything fancy here, we're just rebuilding the code using a make file, and we want to try and switch between the different modules to see what happens. Apologies, no, I probably clicked the mute button too quickly. All I was saying is, yeah, we're not expecting anything amazing from this compilation. Just but it's just a test. Can you download the code, run the makefile, and then swap between the program environments? Does it do as expected? And as I said, the AOCC won't work as default, so we need to make a slight change to makefile to fix it, and it should be a straightforward one, but have a look. Okay, so I'm hoping that most of you are running on the system. As I say, if you're not, do let me know. This is the time for us to now fix it. Right, let me have a look and see if I can share the screen that I was using, and then we can just go through what I was talking about in terms of what you should have seen, hopefully. You can tell me if it was wrong or not. No, it's the wrong screen. One question. No, 1 second, sorry. There we go. I have too many things open. There's always a challenge with this kind of teaching. So let me have a look. I'm in the wrong place as well. So I need to go to my Workfile system. Work. And we can see that I have this thing called, I've downloaded nbody.par.tar.gz and moved it and unpacked it. So I extracted it to release nbody.par.tar.gz. That worked. Then if we go into nbody, we make clean. We have a look at what modules I've got loaded on this session to start with. I've got the create compiler. If I type make, you can see that that's just it's a C program. It's just run the C compiler. It's worked out of the box. Well, at least it's compiled it. I can't guarantee the application's working, but it's compiled it. I do a module restore, programming environment, new, make clean. We can see it's done a similar kind of thing out of the box. And this should be then module restore, programming environment, AOCC. Make clean. If I type this now, we can see, well, it's been a little bit slow at the moment. You see, I'm on the Workfile system. So it compiles each of the individual files correctly on the AOCC compiler. It gets to a point here where it goes, actually, I can't link these properly. Something's gone wrong. I've undefined symbol, POW, POW, log F, square root F, square root, sin F, cos F. And so, as I said, we need to make a slight change to the example so it compiles under this compiler. And those are all good examples of maths libraries, right? So effectively what's gone wrong here is it can't find the maths libraries. All these here, these functions here are not defined in the code, they're external functions. I don't know why. Sorry, I don't know. I can't find them in the compiler, but the other compilers seem to find them quite happily. So that means that those compilers are behaving slightly different. They're linking to the maths libraries without me even having to ask them to. I can change my makefile to fix this. Actually, I just put in this option up here called LD flags. If I look at my actual makefile down here, we can see when we build a program, it links it with this thing called LD flags, which we haven't actually defined in the makefile. Actually, if I put that in there and add in this -lm, link the maths library, and then now I take make quite happily built it here. So just a minor difference between the GNU, the Cray, and the AMD compilers. You can see that I've used the different compilers there. Now there's all sorts of questions about what flags you should use and how you swap between the different compilers to get good performance. Definitely some of that will be in the Archer documentation, particularly over time. I'm not sure how much of it we have in there just yet. Let me go and have a look. Software environment, the modules there. So no, we don't particularly have too much detail on the compilers yet, but over time we will get more detail in there. Oh, actually, there is a useful page which I will share with you, which is sensible to have a look at if you're going to develop code on Archer, and that is the developer's guide. So at the moment, there's a quick start for developers. If you go to the ARCHER2 document site, docs.archer2.ac.uk, quick start for developers, and you can see it talks about the compilers again, the program environments. And then there's a couple of things for different compiler options. So, for Cray compiler, this is a sensible option. C, C++, and the default option. And for the GNU compiler, this is a sensible option by default. So there's some sensible options here. If you're going to use the G4tran with GCC 10 or later, a lot of codes, when you compile MPI codes, complain at the moment, so you need to add in the special -fallow argument mismatch to enable that type check-in to be relaxed. And then there's some optimization flags here that you may want to use to get better performance rather than just the default ones out of the box. And if you want to promote real to 64-bit or 32-bit, these kind of things are here. So there's a bit which I think will develop over time, but there's a nice little bit of documentation on the Archer website covering some of the basic things you might want to know. And then beyond that, there are we can point you to the more detailed compiler documentation on the AMD site or on the Cray site or on the GNU's site. So that's a useful place to start. Good. So, key points there. Development is controlled through environment modules. So these are software that we are using will be controlled through environment modules. We support the GCC, Cray, and AMD compilers. So we need to expand this to the AMD compilers. Compilers are accessed through FTN Fortran, CC for Cray, and capital C for, not for Cray, for C, capital C for C++. These are what we call compiler wrappers, and they're there to make sure you get the optimization settings right for the processor architecture, so that the MPI libraries are correctly linked in and the communication libraries are correctly linked in, and all those kind of things. So that's why we use the compiler wrappers. We don't generally access the compilers directly. We don't type GCC or G4tran, but we use CC or FTN. And if you're porting your own code and you run into problems, then get in touch with us and we can help you out with these kind of issues. Any questions about the software setup on ARCHER2? If not, what we'll do is we'll break now. It's just past 1 o'clock. We'll take an hour for lunch and we'll come back at 2 o'clock to talk about the batch system and how we submit jobs on the compute nodes and how we access the compute nodes. And in the meantime, I'll have a look at those of you who are still having problems accessing the system, and I can see if I can get you through those hurdles just now. Any questions? If not, I shall see you again at 2 o'clock.